A rigid tank with a base area of 0.03 meters square contains water to a depth of 0.7 meters. A tight-fitting frictionless piston of mass 12 kilograms rests on the water surface. A. Calculate the pressure at the base of the tank due to the water only. B. Determine the additional pressure on the water due to the piston. C. Calculate the total pressure at the base of the tank. And D. Find the total force exerted on the base of the tank. Okay, let's solve it. So we have our solution. The base area of the tank, which is A, was given to be 0.03 meters square. And the depth, that is H, is 0.7 meters. And the mass of the piston, which is M, is 12 kilograms. So 12 kilograms. We know density of water to be 1000, kilogram per meter cube. Okay. And also gravity, which is G, is 10 meters per second square. Okay. So question A, we are to calculate the pressure at the base of the tank due to the water only. So we are calculating the pressure provided by the water only. So A, we know pressure, which is P. Let's make it pressure of the water. That's PW to be density of water times the gravity times the depth, which is H. So H, let me write the H well. Okay. So therefore this will be equal to density to be 1000 times gravity is 10 times the depth, that is the height, 0.7. So pressure exerted by water will be equal to, by using calculator, 1000 times 10 times 0.7 will give us 7000. So 7000 Pascal. Okay, let's move on to B. So question B, we are to determine the additional pressure on the water due to the piston. So we are to calculate for the pressure exerted by the piston onto the water. So let's make it pressure of the piston. So this will be pressure of the piston, that PP is equal to, we know pressure to be force over area. So force over area. But we don't have force, so we first have to calculate for the force before we can then calculate for the pressure of the piston. So we have force, which is F, to be mass times gravity. So force will be equal to, the mass of the piston is 12 times the gravity, which is 10. So this will be equal to 120 Newton. Okay. So pressure of the piston will be equal to force, which is 120 divided by the area. The area, which is 0.03. So 0.03. So therefore, pressure of the piston will be equal to 4000 Pascal. 4000 Pascal. Okay, let's proceed. Question C. Okay, calculate the total pressure at the base of the tank. So we know the base of the tank, the pressure at the base of the tank, let's make it PT. That's the total pressure to be equal to the pressure exerted by the water and also the pressure exerted by the piston. So this will be pressure exerted by the water, that's PW, plus pressure exerted by the piston, that's PP. So PT will be equal to the pressure of the water is 7,000 plus pressure of the piston, which is 4,000. So adding 7,000 to 4,000 will give us 11,000. 11,000 Pascal. So therefore, the total pressure at the base of the tank is 11,000 Pascal. Let me write it well. Okay. Let's move on to question D. So D, find the total force exerted on the base of the tank. So we know the total pressure on the base of the tank to be 11,000 Pascal. And we have the area of the base of the tank to be 0.03 meters squared. So you have pressure to be equal to force over area. So to calculate the total force is by making the F, which is the force, the subject. So F is equal to pressure times area. So total force will be equal to total pressure, which is the 11,000 times the area of the tank, which is 0.03. So total force will be equal to 330 Newton. So therefore, the total force exerted on the base of the tank is 330 Newton. Thank you very much. Please like, share, leave a comment, and once again, follow and subscribe for more. Bye bye.